Very good day to all of you. Today we are going to learn the curvature of a vector value functions. I'm Tay from FKEE UTHM, Universiti Hussein. Curvature is actually the measure of how sharply a curve in two space or three space bends. Definition of curvature is as follows. Let's see a smooth curve in the plane of space of 3D given by Rs, where S is an arc length parameter. The curvature at S is given by curvature, the simple kappa here, equal to the magnitude of dts or equal to the magnitude d prime s. Example 1. Find the curvature kappa for a line, a straight line, r in the parameter arc length s equal to 3 minus 3 over 5s in I component plus 4 over 5sg. This is a straight line function. Therefore, component I, if we let it equal to x, so this will have x equal to 3 minus 3 over 5s, and then component if we let it equal to y, so y equal to 4 over 5s. So this is a straight, parametric equation for a straight line. Okay, and then to find the d prime s, first of all we have to find the r prime s. R prime s is ddsk, the r here, at each component. So we have it negative 3 over 5, okay, negative 3 over 5 I plus 4 over 5 g. And the magnitude r prime s, we will square root, and then each component we will square it, so this will be 9 over 5 plus component j is squared 16 over 25. So we get this is 25 over 25, so which is 1. You translate your ts tangent vector in terms of s will be r prime s divided by magnitude r prime s. So r prime s is negative 3 over 5 I plus 4 over 5 g. The magnitude is r prime s is 1. Okay, and then we find the t prime s. Ts doesn't cascade parameter of s, that's why 3 prime s will have a 0 I plus 0 2. The translate magnitude t prime s, magnitude will have 0. That's why the kappa is actually magnitude t prime s equal to 0. Because this is straight line, that's why straight line the curvature is equal to 0. Straight, this is how short a curve is bends that. How short a curve bends. A straight line, of course, straight. That's why no there's curvature is equal to 0. Okay, that's why curvature of a line, a straight line is 0. Same unit tangent vector is always in the same direction. Or a straight line doesn't curve. Its curvature should be 0. Example here. Show that the curvature of a circle of a radius r is kappa equal to 1 over r. Okay, and this is a circle with radius r and making an angle theta. Angle theta. So, okay, this is the figure shows a circle with radius r and angle theta. So, okay, R in terms of theta will be the R cos theta I plus R sin theta G. Component I is x, okay? For circle the parametric equation, we have x equal to R cos theta, component J is y equal to R sin theta. Okay, and then we know the arc length of a arc length circle S is actually R theta. So theta will be S over R. That's why R in terms of S, okay, in terms of arc length will be R. Replace theta by S over R. R sin S over R G. And then find the R prime S. It differentiates each component respect to respect to S. So differentiate cos negative 1 over R and then multiply R sin S over R and component I, differentiate sin, R, this is cos S over R G. Differentiate cos at the negative 1 over R sin S over R. So we need to take R and R here. So differentiate sin 1 over R, differentiate sin S over R. Okay, we have 1 over R cos S over R. Then we find magnitude R prime S. Magnitude R prime S. We have square root. So spread the component I. We have a sin squared S over R plus cos squared S over R. So sin squared S over R plus cos squared S over R. We get the magnitude of R prime S is 1. And then next step we find the TS. TS is actually the R prime S divided by magnitude R prime S. So TS TS is R prime S, which is negative S over R I plus cos S over R Gn. So it's negative S sin S over R at component I plus cos S over R at component G. Magnitude R prime S is 1, so this is a TS. And then we find the T prime S. T prime S, differentiate TS respect to S. So we have negative 1 over R cos S over R at component I, negative 1 over R sin S over R at component G. And then the curvature kappa is actually magnitude T prime S. We find the magnitude T prime S first. The magnitude T prime S square root square each component. So we have 1 over R squared cos squared S over R plus sin squared S over R. So we squared component I, 1 over R squared cos squared S over R squared component J. So we have 1 over R squared factor out, sin squared S over R. Cos squared S over R plus sin squared S over R is 1. So we have it square root 1 over R squared, which is 1 over R. Okay, that's why kappa is magnitude of T prime S which is equal to 1 over r. It defines that. This example, maybe in the first example we have shown curvature of a straight line is equal to 0. Curvature of a straight line is equal to 0. And then curvature of a circle of radius r is kappa equal to 1 over r. So this is first step. Express r in terms of theta, and then arc length s is r theta. So theta is in terms of s over r. Then we find a step. So r in terms of s, r is function of s, and then find r prime s. Theta of find magnitude r prime s. Okay, and then find the unit tangent vector in terms of parameter s, and then t prime s, magnitude t prime s. Lastly, kappa is exactly magnitude t prime s is equal to 1 over r. Okay. The notes here, a circle has the same curvature. Okay, a circle has the same curvature at any point, where the curvature of the circle kappa is 1 over r. So when a circle with a large radius, 1 divide a large number, we have a small curvature. And circle with a small radius, 1 divide a small number, we'll get a bigger number. So a small radius will have a large curvature. Okay, to find the curvature of curve C by using the definition of curvature, kappa is actually equal to magnitude dTs of d prime s. Okay, we need to write the curve in terms of arc length parameter rs. Okay, but because the curve C of the vector value function is frequently defined by RT, so it's often useful to have a coding formula for kappa, a formula for the curvature. Okay, because normally vector value function is expressed in terms of parameter time t. So the curvature of the vector value function RT kappa is also given. Okay, defined using this formula. Kappa will be magnitude t prime t divided by r prime t. Okay. Or if the magnitude r prime t here is kappa t prime t divided by r prime t, or easy we define the second version, which is magnitude r prime t cross product with r double prime t divided by magnitude r prime t square root, magnitude of r prime t power 3. For example 3, so here we are put out the formula for curvature using two versions in terms of t. So find the curvature of the curve given by rt equal to 2ti plus t squared j minus 1/3 t cubed k. First of all, you show using the first formula here, which is magnitude t prime t divided by r prime t. So from rt we find r prime t. In order we can find t and then t prime t. So r prime t is ddt each component of rt. Another notation for vector. So dt 2t is 2. ddt t squared is 2t at component j. So negative t squared at component k. So 2i plus 2j minus t squared k. And the magnitude r prime t, magnitude r prime t, square each component and sum it. So 2 squared is 4, 2t squared is 4t squared, so plus t power 4. We try to find this. 2 plus t squared power 2. 2 squared is 4, 2 and 2 4, and t squared 4, t squared, t squared, squared, t power 4. So That's why the magnitude r prime t we can get is t squared plus 2. Okay, we have here magnitude r prime t already. Okay, to get t prime t, get t prime t, we should get dt, unit angle vector t is actually r prime t divided by magnitude r prime t. So r prime t we have here 2i plus 2tj minus t squared k divided by magnitude k magnitude r prime t, which is t squared plus 2. If magnitude r prime t is if normally magnitude r prime t is function of t, we prefer to use this formula. The r prime t cross r double prime t divided by r prime t. But here we'll show you two versions. Okay, and because we have to use quotient rule to do the differentiation. In this case, we have the u over here, and then we will calculate dt uv, we will get b u prime minus u b prime divided by so for t prime u t prime t. We have the b, which is t squared plus 2. Okay, and then ddt u, which is vector 3 t squared plus 2, and then your ddt u, which is vector, differentiation of vector, you still have a vector. ddt 2, we have 0. ddt 2t, we have 2. Okay, ddt negative t squared, negative 2t at component k. So minus u, which is 2t negative t squared. It differentiates the v, which is 2t, and divided by v squared, plus 2 squared. Simplify it. Okay, this one component I is 0, so that's why component I come from the second component I here. But this one component I 0, so minus 2 times 2t, so component I have negative 4t. Okay, component J okay, total we have 2t squared plus 4 minus 4t. 2t squared, and then minus 4t squared. 2 times 2, I have 4, and then 2 times 2, 4, 2t squared, left here not enough space, that's why here. 2 times 2, 4, 2t squared minus 4t squared, so 4 minus 2t squared. Okay, and then component k, here, this one. Okay, component k. So I will have here negative 4t, and then negative 2t squared, 2t cubed plus 2t squared. So just left negative 4t divided by t squared plus 2 power 2. Okay, component k, we did again. Negative 2t times 2. So negative 4t. Negative 2t times t squared, negative 2t cubed, and then here negative, negatives are plus 2p cubed. So just left negative 4 at component K. Okay. Then you put in number 4 divided by number 2. That will be magnitude of number in number 4 is actually not yet t prime t, and then we need to find the magnitude of the t prime t. The number 4 is actually t prime t. We have negative 4t, 4 minus 2t squared at component j, negative 4t at component k, divided by t squared plus 2 power 2. Negative 4t, 4 minus 2t squared, negative 4t. And then we find number 5, we find magnitude t prime t. Here we have the square root, square each component. So negative 4t, you square it, we have 16t squared plus 4 minus 2t squared okay, plus here 16t squared. Okay. Denominator square it, we have t squared plus 2 squared. Okay, expand it. The 16 minus 16. So 32t squared. Okay, expand the second term here. We have 16 minus 2 times 2 times 4 minus 16t squared plus 4t power 4 divided by t squared plus 2 squared. Okay, so 32 squared minus 4t power 4. 32t squared minus 16t squared will become plus 16t squared plus 16. Okay, divided by t squared plus 2 squared. So the magnitude t prime t. Simplify it, factor out 4. 4. So t power 4 plus 4t squared plus 4 divided by t squared plus 2 squared. 4 is outside. Try to find out t power 4. It is t squared plus 2 squared. T power 4, 4t squared plus 4. Okay, numerator square root 4 is 2. And t power 4 plus 4t squared plus 4. Factor out, we have t squared plus 2 power 2. Okay, divided by t squared plus 2 power 2. So the answer we have the magnitude t prime t is 2. Okay, this one I should power 4. So okay, when find magnitude t prime t, each component is squared. Denominator I should square it also. So this is 4, this is 4, this is 4, this is 4, this is 4. This component square it is power 4, power 4, power 4, power 4, this is power 4. Then we have 1 over t squared plus 2 power 2. So we have 2 over t squared plus 2. So this is t prime t. T prime t. Okay. So t prime t, we get 2 over t squared plus 2. magnitude T prime T is 2 over T squared plus 2. Okay, and then the magnitude R prime T is T squared plus 2. Okay, magnitude R prime T is T squared plus 2. So kappa is actually magnitude T prime T divided by magnitude R prime T, which is 2 over T squared plus 2. Okay, divided by T squared plus 2. Reverse it, 2 over T squared plus 2. Okay, and 1 over, this is divided by 1. So 1 over T squared plus 2. Okay, so we get kappa is actually kappa that I obtained. Kappa is 2 over T squared plus 2 power 2. So I said, if you give a choice, if magnitude R prime T is not constant, it will be easier to use this formula. Magnitude R prime T cross with R double prime T divided by R prime T power 3. So now using this for let's say this is what we call the second formula. This is the third. First total, we have 3 formulas to find curvature. First is magnitude T prime S. Okay, that's the second formula we call as magnitude T prime T divided by magnitude R prime T. The third formula is magnitude of the cross product of R prime T cross with R double prime T divided by magnitude R prime T cubed. So using the second formula, we get the curvature is 2 over 2 over bracket T squared plus 2 squared. Okay, now we check back using the first formula, the third formula. Using the third formula, so this is the third formula. So back RT is actually 2TI T squared negative 1/3 T cubed. And then phi R prime T. With R prime T, we have 2I 2T negative T squared K. Okay, and then you find magnitude R prime T 4 plus 4T squared plus T power 4. T squared plus 2 squared. T power 4, 4T squared plus 4. You get 6T squared plus 2. Using the third formula, we need R double prime T. R double prime T. So using the third formula, from RT you find R prime T, and then you find magnitude R prime T, you find R double prime T. In ddt RT, 0. ddt 2T, component J is 2. ddt K negative T squared K, you get negative 2T at component K. Okay, and then it needs the R prime T cross with R double prime T cross product. Finds R prime T cross with R double prime T. R prime T, we have 2I, 2T, negative T squared, R double prime, we have 0, 2, negative 2T. So the cross product, let's do it for the cross product. It initially you close the I. You want to get a cross product, the result is a vector. You close the I here, close I, cos it. So using the main diagonal, deduct it, other diagonal. So 2t times negative 2t, we have on the I, negative 4t squared, okay, minus negative plus 2t squared. This component j is negative. Okay, component j negative. And then close it again the same. Main product 2 times negative 2t, which is negative 4t, minus this 0. So because 0 times negative t squared, so minus 0. This is component I. Okay, and then component j you close it. Okay, component k, component k you close it. So main diagonal here, 2 times 2, 4, it minus 0. So we should get here negative 4t squared plus 2t squared is negative 2t squared 4tj 4k. Okay, and then number 6 defines magnitude r prime t cross r double prime t, which is we have the square root square each component 4t power 4 plus 16t squared plus 16 squared. 4t power 4, 16t squared plus 16. Factor out 4. So you have t power 4 plus 4t squared plus 4. So which is 4. This is t squared plus 2 squared. T power 4, 4t squared plus 4. So magnitude r prime t cross r double prime t, you get 2 times t squared plus 2. 2 times t squared plus 2. Okay, and then page 6. So 7. Kappa is magnitude r prime t cross with r double prime t divided by magnitude r prime t power 3. Cross product, the 2 times t squared plus 2. 2 times t squared plus 2. Magnitude r prime t power 3. T squared plus 2. So this is t squared plus 2 power 3. So we have 2 over t squared plus 2 power 2. Okay, this is using the third formula. 2 over t squared plus 2. So means they are shown here. The example, if the vector value function is given in Rt, you can use the second formula. Is t times t divided magnitude t times t divided by magnitude r prime t. But if the magnitude r prime t is actually a function of t, you need to differentiate your pt using quotient rule. So in this case, the third formula will be interpretable easier. But okay, make sure you do the cross product carefully. Okay, so you have shown using formula 2 and formula 3. Then on Rt you get r prime t, and if r prime t is Okay, square root and then square each component and sum it to get t squared plus 2. Unit tangent vector dt is r prime t divided by magnitude r prime t. So this is step 1 divided by step 2. And then t prime t, since numerator, denominator are function of t, you need to use quotient 2. Where ddt ut is a p u prime minus u p prime divided p squared. So this is a p is here p squared plus 2. And then ddt the u, ddt the vector, the result still vector, dt2 0, ddt 2t is 2, ddt negative t squared is negative 2t. So minus k2 down, ddt the b, ddt t squared plus 2 you have 2. And then we will just simplify about because I have less space, that's why if you got space you can expect carefully simplify it. So you get this is t prime t. So t prime t. Then you find magnitude t prime t square root. Okay, numerator, okay, you square each component. Denominator just now is power 2 is squared power 4. Okay, simplify the magnitude t prime t, you have 2 over t squared plus 2. Translate curvature using the second formula, which is magnitude t prime t divided by magnitude r prime t. You get 2 over t squared plus 2 power 2. Okay, the third formula is actually curvature in have a magnitude r prime t cross with r double prime t divided by magnitude r prime t power 3. So for rt, you find r prime t, magnitude r prime t, and then differentiate r prime t one more time to get r double prime t, and you find the cross product of r prime t with r double prime t. Okay, the cross product, the result is vector. Okay, for example, component I close it, and then you left a determinant of 2 by 2. You use a main diagonal product of main diagonal deduct with the other diagonal. Okay, only at component j negative, because you have 2 by negative 2t, negative 4t minus 0 times 2. So you get the cross product. You find the magnitude of the r prime t cross with r double prime t. Then lastly, the curvature is magnitude r prime t cross with r double prime t divided by r prime t power 3. So in here we have shown the curvature of vector value functions using two formula, and we have shown also the curvature of a circle. We get kappa is 1 over r. Okay, and so shown the curvature of a circle. Initially r becomes theta, and then part length s is r theta, so you change theta into s, okay? Then find r prime s, magnitude r prime s, then you can find ts, which is r prime s divided by magnitude r prime s, and then you find t prime s based on t prime s. Okay, ts is r prime s divided by magnitude r prime s. Okay, and then if ddt ts, you get t prime s, and then later on magnitude t prime s, so which is equal to the curvature. So example 1 is actually the curvature of a straight line. Sinking, find r prime s, magnitude r prime s, ts is r prime s divided by magnitude r prime s, and then from ts, find t prime s, which is ts, the ts, then you can find the t prime s, which is equal to the curvature. With this, thank you for your attention.